Hello everyone, welcome in. We're on the very last topic for this semester. It's going to be something called object-oriented programming. This is a new type of programming that we've kind of seen, but we'll kind of formalize it today. So just a heads up, we're at the last few weeks. Next week there's going to be a practice final released, and then the final exam will be the very last finals week. Okay, so let's see. The final exam, once again, it's scheduled for a certain day. It's going to be on finals week, which is a different schedule. Our final will be on Friday, 1 to 3:50 p.m. May 30th. Okay, cool. So let's see. Yeah, once again, next week we'll do a practice. All right, the practice is going to be just like the practice midterm. I encourage folks to go to the previous midterms, right? The previous midterm and also the practice one. This will give good practice for the future. The final exam is cumulative, meaning that all of the previous topics will be included. All right, let's jump into the very last topic though, object-oriented programming. Okay. Let's see. One of the first type of object that we've seen in this class was something called a turtle. So in the very beginning of class, we were actually doing object-oriented programming right away. Right? On the first week, we did something called using the turtle. This is lesson number 2. Right? We imported some library and used it to visualize certain things. Right? Like here we imported the turtle as TU. Right? By the way, TU is an object. Right? And we ended up using this object to call functions on it. Right? For example, we called the new function. Right? The dot new is a class function. So here I'll put something here. I'll just comment this real quick. This is a class function. Right? It's pretty much, it belongs to this turtle. Right? And we did some other types of class functions like dot move. Right? And we did some other stuff like turns. Okay, so we did turns, moves, and we also did stuff with the attribute. Right? Like scrolling down a bit, an attribute doesn't have parentheses at the end of it. So this is not a function, right? This is accessing an attribute within that turtle and then setting equal to some number. So this is called we're overriding class attributes, or more specifically, overriding object attributes. Right. Okay. So yeah, we've been exposed to some of this. Right. Let me pull up a sneak peek demo real quick so folks are refreshed on this. So I'm just going to open up a playground tab and make a sneak peek for object-oriented programming. So let me make a new notebook. I'm going to call this object-oriented programming sneak peek. Okay, OOP for object-oriented. We're going to see a couple examples here. First, I just wanted to refresh folks on the turtle. And then next, I'm going to do another type of example that's closer to an RPG game representation. So let me start off with a turtle. Right, in the first week, we imported a turtle right here. I'm going to import this in a different style so we can have a bit more control over it. Because this earlier style, the import Jupyter turtle as TU, is actually only allowing us to use one object, one turtle object. But if we import this in a different style, we'll be able to spawn multiple turtles. So I'm gonna change this import statement a bit. I'm gonna change it to from Jupyter turtle.turtle import capital turtle. I'm changing this up a bit because the capital turtle is a more general instance. Okay, so I just change that up a bit. Okay, so this first line is saying access a library. Right? There's a library in our file system called jupyterturtle.turtle. And inside that library, there is a class called turtle. So I'm just going to comment this real quick. This is importing the turtle class from the library jupyterturtle.turtle. All right, we're importing a turtle class. You can think of a class as a cookie cutter. Right? A cookie cutter means it's not the actual thing yet. It's not the actual thing. The cookie is the actual thing. So the cookie in this case, I'm going to call it like TU. Right? In the past, we've called it TU. This is not going to exist yet. Right? If I were to run this cell, it says TU is not defined. Right? This is because we never initialized this thing yet. Right? This thing is actually going to be an object that comes from the class turtle. So I'm saying TU is equal to uppercase turtle, right? And this is gonna, I'm gonna comment this real quick. This is constructing an object named TU. Right? It's constructing an object named TU from the class turtle. Okay, so just to kind of talk about objects and classes, right? I'm going to be using these terms a lot today. A class is a cookie cutter, right? In this case, the cookie cutter is a general turtle, right? And then an object is the actual cookie, right? The actual thing made from this cookie cutter. So TU is the actual object cookie. Okay, we can use this object to do multiple things, right? Like there's actually a help function. Right? I'm going to do a help. Or here, you might have seen this a while ago. Right? Pretty much, this is a Python function that brings up documentation on whatever we specify. So I'm going to say help on TU. Right? This is saying, hey, give me help on this object. And it's going to give us documentation on this class called turtle. Now, documentation meaning all of the available class functions and attributes. So we've used a lot of these class functions already, and these attributes too, right? We've used these color, right? We used the heading, the position. Right? So yeah, this is just a help real quick. Okay, so let me delete this cell real quick. All right, what did we do so far? So we constructed a turtle named TU. I'm going to construct another one in just a bit. All right, we're going to have two turtles. So I'm actually going to rename this to TU1, right? Because I'm planning on making two turtles on the same canvas later. Okay, so TU, I'm just changing the name to TU1. There we go. We constructed it. And I'm going to go ahead and create the canvas. Right? So this class has a function called new, right? tu.new. And all that does is it creates a canvas for us. Right? You can see that over here. If you did like help tu1, right? One of the functions here is new. Right? So we've been doing this. Right? tu.new. Okay, so this is calling a class function. Right? A class function typically has a period before it, right? And then the object name before that period. Right? So it's object period function. Right? This is a class function. Some other class functions we've seen were moving and turning, right? Like tu.move 50, right? And then this is just going to call another class function. Just going to move it up 50 pixels. Okay, so these are calling class functions. We've also, here, let me just comment this again. Calling another class function. Okay, there's also some things attached to the class or object. They're called attributes. Right? Attributes don't have parentheses. Like, remember we were able to access its position, right? Like tu1 dot position. Right? This returns us the x and y coordinate. Right? So once again, there's no parentheses after this. Right? This is accessing the object's attributes. And we're accessing the object attributes. In this case, I'm just going to print it out just so it looks a little neater. So I'm going to go ahead and print this. All right, print this. Let me put it in an F string. Let's see, position. Okay, I'm just going to put this in an F string so we can see its position. Okay, so let me run this. Okay, there we go. We ran it, right? It moved it up 50, and then we print out the object's attributes, right? The position here, right? The x and y, 0, 50. That's where it's at currently. All right. There's also other attributes, right? Like you might have seen the heading attribute, the color attribute, right? So going back to lesson 2, right, all the way to the beginning, right? You might remember there was a width, right? There's a color, right? There's a bunch of them. So let me play around with this, right? Like maybe we could print out the heading as well, right? The heading tells us what direction the turtle is facing. So this is tu.heading. It's all we're doing is accessing the attributes. Right, so there we go. And then the print statement is showing the position, right, and also the heading. Right? 0 meaning that it's facing north. Okay, so hopefully people are cool with this so far. This is just a review of turtles. Right? In particular, I wanted to bring up object-oriented programming. So that might be why you see all these comments. All right. Cool, so we've done something called a constructor, right? Constructor takes a cookie cutter, right? The cookie cutter is capital turtle, and then it creates a cookie, right? In this case, the cookie is tu1. Right? So we use that cookie to call class functions, right? And we also use that cookie to access attributes. And once again, the functions have a parentheses after it, but the attributes don't. Okay, let me just change one more attribute real quick, so folks because we're going to create 2 different turtles on the same canvas in a bit. And let me just change the color. Actually, I'm just going to change the tu1 color to like red. Right. The reason why is because I'm going to make another turtle right now actually. So tu1. Oh, I made a mistake right here, by the way. Earlier I said tu. It should have been tu1. Right? If it's just tu, is using the previous one from a long time ago. Yeah, I meant tu1 here. Okay, let's see. Let me spawn another turtle. So on the very top cell of this second cell, right, I'm gonna construct another one. Right, I'm gonna construct one called tu2. I'm gonna set it equal to a turtle again. Right, so this is the same thing. Right, this is constructing another object. Right, constructing another object named tu2. Right, so yeah, 2 separate objects, but the same class. Okay, cool. So here's the cool part. We're gonna have 2 turtles now. Right, like here I'm just gonna say tu2, right, dot new, meaning it's gonna create a separate canvas for this turtle. Right, and let me just change this tu's color to something else like green. Right, and let me do some rotations. I'm going to turn it 90 degrees counterclockwise. So this is a turn 90, and I'm going to move it. tu2.move 50. Okay, so all I did was create a second turtle. I made another canvas for it, and have it move around a tiny bit. So let me go ahead and run this real quick. So I'll run this. Okay, there we go. We just ran it. Okay, here's turtle 1. All right, turtle 1 is red, and all it does is move 50 up. All right, but let's scroll down a bit. Because we scroll down a bit, there should be a brand new canvas. Okay, there we go. Scrolling down a tiny bit more. Right, here's a brand new turtle, right? Second turtle. And this one is moving in a different direction with a green pen. Right, so that's what's happening right here. Right, we got 2 canvases and 2 turtles, right? 1 in each of them. Okay, and we can access each of their attributes. Right? Remember this one? This is the turtle 1 attributes. So I'm just gonna make this print statement a little nicer, right? Turtle 1 attributes. Okay, so this is turtle 1 attributes. Let me print the second one as well. So I just copy and pasted this first line. I'm just gonna change this to 2. Right? Turtle number 2. Right. All right, there should be some cool stuff now. So let me run this. All right, once again, we have turtle 1 moving up, and we have turtle 2 moving left. And then the print statements are down here. All right, you see the print statements. It's showing each object's attributes. All right, the first turtle is in a different location, and the second turtle is in another one. Right, heading 90. This means it's heading west. Okay, cool. Hopefully people are cool with this so far. We can combine these canvases. We can have multiple turtles on a single canvas. Currently, there are 2 separate ones, right? But let's go and combine them. Basically, to combine them, we just need to comment out this second new, right? Because this second new is actually creating another canvas. So let me comment this out. Right, so I commented it out, and now we just now combine them. Right? See, I commented out the second one, meaning that the green turtle is no longer here. Right? So we're not even seeing it. If anything, we just need to make a way to have them share the same canvas. So there is an attribute attached to every single turtle. It's called the underscore canvas. So over here, I could say something like, I could say, hey, take the TU2's canvas. Right, so this is accessing the canvas from the second turtle. Right, I'm gonna share it with the first one. Right, meaning I'm gonna set this equal to the first turtle's canvas. Right, underscore canvas. This is an attribute. It's pretty much pointing at the current board. Okay, so this is actually share the same canvas. All right, that's what that line is doing. Okay, so let's go ahead and run this. Okay, so they should be on the same canvas now, right? There we go. Right, we have the red turtle going up, and then the second turtle going left. There is one caveat to this library, though. It's only able to render, I think, 1 turtle at a time on the same canvas. But yeah, there are technically 2 turtles here, right? We just don't see the first one because the second one kind of drew it here. So I'm actually gonna hide these turtles because the library only shows 1 at a time. Right? But as long as people kind of see what's happening, right? There are 2 turtles kind of moving on the same canvas. So let me just hide these real quick. I'm just gonna hide them down here. tu.hide or tu1.hide, and then tu2.hide. Okay, so I'm just hiding them, right? So turtle 1 is going up, turtle 2 is going left, right? And we can change some stuff around, right? Like turtle 1, if I were to move it a tiny bit more, like tu1.turn negative 90, and then move it 50. Right, so all I did was add 2 more commands to here, right? So now we see that the first path changed, right? Turtle 1 goes up and then goes another direction, right? And turtle2 moves this way to the left. Okay. Yep, and there we go. We're printing out their current attributes. All right, hopefully people are cool with this so far. So yeah, the point of going back to this turtle is to kind of talk about what object-oriented programming is. Right? You can think of object-oriented programming as creating your own variable and using things within that variable. Right? For example, here in this first line, we created an object named tu1, right? That comes from this turtle class. So this is kind of like making a variable, right? We're initializing a variable, but it's a special type of variable, right? It's called an object. The difference between objects and variables are the objects have a lot of functions attached to them, right? Like these objects. If we look at the help, right? This object has a lot of functions. Like we can do a dot hide, right? We can do dot new, and a bunch of other functions that we've seen. Right, so objects are like fancy variables that come from a certain cookie cutter class. All right. Okay. We have been doing a lot of object-oriented programming. Like in the very beginning of class, we talked about lists. You might remember lists have a bunch of functions attached to them. So I could Google up something like lists methods or list functions in Python. Okay. Let me go to primary documentation over here. Right, so this is kind of like the documentation on a list. It's kind of like if we were to do like a help on the list over here. So let me just do like a help on a list to see what that does. Right, see, I just say, hey, give me documentation on the list. Right, a list is a class that has a bunch of functions attached to them. Right, there's so many of them. I think we've seen this function called remove, right, which is deleting something from the list. We've seen a function called append. Right, append adds something to the end of the list. We've seen other stuff too, like insert. Yeah, insert right here. Right, so yeah, this is just documentation. That's what I was pulling up on this web page earlier. Right, this web page is kind of like formatted a little neater. Right, this is saying, hey, what functions are available on the class list? Right, well, you could do a list.append, right, list.insert. Right, we can do a bunch of stuff. Right, so yeah, we've worked with objects before. Another example is a string. Right, we've seen some string methods. Like here, let me just Google it. All right, string methods. Let me go to the primary documentation. There we go, string methods over here. Okay, yeah, what have we seen? We've seen a string. Oh, we've used this right here, format. I think folks use this in their Mad Libs project. Right, basically, you put a string and then a period in format, right, and then whatever arguments you put in here will be put in the curly braces. So we use format. What else have we used? Oh yeah. These are functions that are attached to strings. Oh, maybe. Let me see. There's an insert. Oh yeah, those are list functions. Yeah. So the insert and delete stuff, that was brought up earlier. So yeah, strings and lists are kind of similar. Yeah. You can apply them. Yeah, you can treat a string as a list if you want, because technically a string is a list of characters. But yep, the remove. Yep, exactly. Yep, removes all items from a list. Yeah, tons of things. But yeah, earlier someone in class was talking about the similarities between strings and lists. Yeah, they're very similar. A string is a list of characters. Okay, so yeah, we're just going over class functions. So let's go back here. All we did so far was did a bunch of object functions with turtles. Let's move on to a different type of class though. Like here, let's bring up a different scenario. Like let's say maybe some folks are playing games. Have folks ever played like RPG games, like role playing games? Uh, yeah. Like any games, Marvel Rivals. Yeah. In particular, any general game with some sort of statistics. Like how some games you have like a health bar, you got a stamina, you got a mana. A lot of games have something like this. Right? This is a player. Right? We're representing a player with 3 attributes. And so think of it as a turtle. Right? A turtle has a position attribute. It's got a heading attribute. It's got a color. Right? But with the players, right? Players in RPG games, their attributes, they have health, mana, stamina. They probably have an inventory attribute as well. Just to be more specific, like Oblivion, right? This is there is an Oblivion remastered that came out like a couple weeks ago. This is not the remastered one, but we see that in those types of games, right? The player has some certain statistics to it. So yeah, let's take this scenario and create our own representation. Right? But basically, we're going to use Python, create a object, create a class called player, and then folks might be able to make their whole RPG game from it. All right. So let me go back to this notebook, and then I'm going to scroll all the way to the bottom because we're kind of done with the turtle. So yeah, let's scroll to the bottom real quick. Okay, scrolling to the bottom. We're done with the turtle. I'm going to delete this help function because this is kind of bloating the terminal. Okay, I'm just deleting that help. Let me create a brand new cell here. Right. I'm just going to put a divider here. You don't have to do this. I'm just going to create a divider. This is called the player example. Like an RPG game. RPG scenario. Okay, all I did was made a markdown cell. Let me do a code cell down here. Okay. All right, actually, let me make 2 cells because I'm going to do things a little out of order. Okay, imagine if I were to construct a single player, right? Like imagine you're playing some game. There's a hero. There's an enemy. Let's deal with one for now, right? Let's just deal with the hero, right? Let's say I were to declare an object called hero. All right, so I'm just gonna type hero, capital H. Right, it actually doesn't matter. It could be lower as well. I'm just gonna go capital, right? But it's not gonna run. Right, hero is not defined. Right, this makes sense because it doesn't exist yet. Right, we need to make it exist. Right, so one way we can make it exist is by saying set this equal to some cookie cutter. Right, so we're attempting to make a cookie, right, an object from a cookie cutter called player. Right, this is like the turtle example earlier. Remember in the turtle example we did tu1 is equal to turtle. It's very here. Give me 1 second. My projectors are flickering again. Oh no, I'm not in the lab at all. This is a sneak peek. It's a yeah. For folks who are wondering, yeah, I don't have any lessons or lab open. Just creating a brand new one from scratch. So anyways, you might remember our turtle, right? This is creating a object from a cookie cutter called capital turtle. And that's what I'm attempting to do down here. I'm attempting to construct an object named hero. Thank you. Right, I'm attempting to construct an object named hero from the class player. Right, but it's now let me run it. Okay, it says player is not defined. Okay. All right, let's see. Oh, sorry, folks. My projectors are glitching again. Okay. If this happens again, I'm going to restart. Okay. Python kernel is saying player not defined. The bare minimal syntax we need to make this class exist is with the keyword class. Right? So right above this cell, I'm going to create something called a class player and then colon. Okay. I think that's the bare minimal syntax. If anything, there should be a doc string that kind of talks about what this does. Right, so let me just put a doc string in here real quick. Right, in this case, this is a class that represents a player. Right, I'll just keep it simple for now. Okay, so there we go. That's bare minimal syntax. And then now let's run this. Cool. So we successfully constructed an object named hero, right, coming from the class player. This is a cookie cutter, by the way. Right? We're going to define what this cookie cutter does in just a bit. Now, the reason why I keep calling it cookie cutter is because we can spawn multiple types of players. Right? In this case, we're just spawning one. Right? We'll do a hero, but later on, we're going to spawn an enemy and then have them kind of interact with each other. Okay. So we constructed an object named hero, right? But let's go through their statistics. Right? Like typically in RPG games, they have health, mana, and stamina. All right, let's see if we can access some of these things. Like, let's see. Like, do we have access to an attribute called? Let's see. Let's go hero.health. All right. We're attempting to access the health attribute. So if I were to print it, hero health is, right, let me just put this in an F string. Okay. So this next line is attempting to print the hero's health. But guess what? It's not going to exist. Right? It says player object has no attribute health. Oops, there goes my projector again. Okay, so there's no attribute named health, meaning we have to define it first. Okay, you know what? Here, sorry folks, I'm recording for pausing. I'm gonna pause the recording here real quick and then restart this thing. Folks on Zoom, give me 1 second. All right, I'm back. Cool, sorry about that, folks. My projectors are glitching. Okay. Anyways, we're back here, right? There's no attribute health. This means we didn't define it, right? We're attempting to access something that doesn't exist. So one way we can define it is just by initializing it in the very beginning. Like in the very beginning, we can just say hero.health is equal to 100. Right, so this is doing something called initialization. Right? We're initializing an attribute, health. Right. So now we should be able to access it. Right? We initialized it, and this should work now. So I'll run it, and there we go. Right. Hero health is 100. Okay. And we can add in some more things like mana and stamina. Right. I'm just going to keep it as health for now, just to keep things simple. Let's see. Typically, these players have actual string names attached to them. Like how in the beginning of some games you can name your player. Like they'll be like, oh, what name do you want to use for the rest of the game? Right, so an attribute would be some sort of string name as well. Like we could say the hero name is equal to something, right? I'm gonna set it equal to some random string. Like let's say, let's go Spider-Man. It doesn't matter. This is now saying the object has two attributes now, right? One attribute is a string that represents their name, and the other attribute is a number that represents their health. So let me update this print statement so we can print out their stats, right? Like let's go. Let me print out the name. Hero. Let me go name and health. Okay, so I'm just updating these print statements. The first one is just going to print out the name, and the next one prints out the health. Right, so let me rerun this. Okay, there we go. All right, so the last two print statements is just printing their name and health. Okay. There goes my projectors again. Okay. Man, I don't know what's up with this hardware. Okay. Hopefully it's not interrupting. Okay, let's populate this class with some functions. Right, like imagine that we were writing a class for other people to use. This is kind of like how the industry might work, right? Basically, you're writing a library, and then giving that library to your coworkers. Right? This way, the coworkers can use that to do their job. Right? In this case, imagine this top cell as a library, and then imagine as your coworkers on this next cell. Right? This next cell, imagine as your coworkers are using your library to interact with certain players. It might be useful to provide a function for the user, right, or the coworkers. We could maybe provide them with a function that does this prints for us. Like this is kind of cumbersome, right? Like we're expecting them to print these items, but wouldn't it be more handy, right, if these didn't exist, right? Like let's say these didn't exist, and we did something like print stats, like hero.print stats. Right, so imagine we did a class function that prints it for us. Or actually, starting, yeah, imagine we did that. So we need to define this function, right, because it doesn't exist yet. It's pointing at hero.printstats. It's saying we don't have an attribute named printstats. So here's the cool part right here, right? We need to tell the cookie cutter to have a function named printstats. So I'm going to go to the cookie cutter up here. Right, so there's the class player. I have an indent. I'm going to define a class function called printstats. So here, give me 1 second. Okay, let's see. Let's define a function called printstats. Okay, there is an indent in here. Right? The reason why there's an indent is because the function belongs to player. Right. So this is going to look a little trippy. Oh man, what's up with my projectors? Okay, I want to restart this one more time. So let me stop recording here. For folks on the recording, sorry about the interruptions. Okay, I'm back. Hopefully this works now. Cool. So we're wanting to print the stats out, right? We're updating the cookie cutter so we can have a function called printstats. So this needs to access certain things. Right? So I'm going to put something here called a self. Right? right? This is going to make sense in a bit, right? In the argument for this function, right, I have a self argument, right? This will make sense in a bit. But basically, this argument is representing the object that we're calling it with. For example, when we call this hero.printstats, right, hero is an object that's being passed into this first argument. So it looks a little tricky, right? Because there's nothing in here, right? Nothing in these parentheses. But in Python, when we call a class function, right, the object to the left of it gets passed into this self argument. Right, so hero gets passed into self, and all we need to do is print the statistics that are attached to self. Right, like let me go ahead and print some f strings. Right, I'll just print out name is, and then here I'm going to put self.name. Right, it's not hero.name anymore, right, because hero is referred to as self here. Let me do another one. Print f, and then health is self.health. All right, let's test this now. So I need to rerun this class definition. Right, every time we update the class definition, we got to rerun this cell. So let me rerun this, play, and let's see if this function invocation works now. So let me play this. Okay, there we go. All right, this line is calling a class function over here. Right, this is indented, by the way. It belongs to the class player. Right, and then this might look weird, but hero is actually the first argument in this function. Right, even though it's not inside of these parentheses, with object-oriented programming, the first argument is left of here. Right, so this argument gets passed into self up here. Right, so we're referring to hero as self, and then we're just printing out the name and health. So that's what's happening there. Okay, so all we did was write a function that prints out their attributes. This way we don't have to do this stuff right here, right? Because it would be kind of cumbersome to expect the user to print this out. Right, so once again, I'm deleting those. Right, so the motivation is we're writing a library to let users have an easier time with certain things. And so imagine here we're writing a library to represent a player, right? And the user is in this bottom cell. Right? Imagine the user as they're downloading your library, and then they're gonna interact with it. Okay, cool. All right. Yeah, yeah. Mhm. Mhm. Oh yeah, good question. Is this relevant to PC or console? It's actually relevant to everything. Yeah, because this is general enough for anything to use, as long as they can run Python. Yeah, yeah. So this is like writing, like we're defining how a class works. Yeah, yeah. Hmm. Yeah, yeah, exactly. Yeah, yeah. We're pretty much just representing some sort of player, so another coworker can use that object and create stuff with it. Yeah, it's pretty cool stuff. For folks who are into game design, you might have heard of Unreal Engine. or maybe Unity. Right, we're really just rewriting things that the Unreal Engine already provides us with. Okay, yeah, that's some good stuff. Okay, let's go ahead and insert another player because I'm planning on modifying this constructor. Now, let me just comment some stuff real quick. So this one's invoking a class function. We're invoking a class function, not an attribute, right? Because it's got parentheses here. Okay, let me construct another type of player. Right? In some RPG games, there's the hero, and then there's a bunch of other, enemies as well. So let me construct another object. All right, let's call this one enemy. Right, I'm gonna call it enemy is equal to player, another player. All right, so we're constructing another separate object, right, from the same exact class. Right? In this case, maybe we could call it like what's an enemy of Spider-Man? Venom. Okay, yeah, Venom is a good one. Okay, so let me set that enemy's attributes name. Right, so enemy.name, and I'm just going to set it equal to a Venom. Yeah, that's a good one. And maybe let me set them to the. Let's say that Venom has a lot of health. Right, so I'm just going to say enemy.health is equal to 200. Right, I'm just choosing some random numbers. I'm just deciding that Venom has more health. Okay, so we just constructed another object. Right, construct another object named enemy from the class player. Okay, let me go ahead and print it out. So I'm going to go enemy.print stats again. Okay, let me run this cell now. So press play. All right, see what's happening here? So we have two print statements pretty much. Right? Each print statement is printing two attributes. Right? So the hero.print stats, right? It's printing these two over here. And then the enemy.print stats is printing these next ones down here. Right? Because enemy, we're calling a cookie cutter, right? The cookie cutter here is print stats. It works with any player, by the way. Right? It's just that enemy gets passed in, and we're naming it self. Right? So hopefully people are kind of seeing what the cookie cutter is. Right? The cookie cutter is this class interface. Right? It defines how the object works. So far, all this object can do is really just print its attributes. But in the future, we're going to add in some more functionality. Like maybe we can allow them to heal or take damage. And we'll do that in just a bit. Okay. Let's see. What else can we do? Okay. Okay, let's see. Let's add in one more functionality. We'll do something called like a take damage or a heal functionality. Like typically in RPG games, when you're interacting with the environment, sometimes you take damage and sometimes you're healing. Let's say for some reason the hero, the enemy takes damage, right? So just for some reason, right? Like let's say the enemy takes damage. All right, I'm just gonna hard code some numbers here, like 20. All right, so I'm just putting up a hypothetical scenario, right? We're saying enemy takes 20 damage. Right? In this case, we're attempting to modify the enemy's health by subtracting 20. Now, that's what we're attempting to do here, but it's actually not going to do anything yet. Right? If we were to run this, right, it's going to say we don't have a function named take damage. This is saying the cookie cutter doesn't know what this function is. Right? So we need to go ahead and define this function. Right? If anything, this function needs to be named take damage. Right? So up here, I'm going to declare another function. Right? And be careful for your indents. Right? Make sure the class functions are inside of it. So I'm going to define another function called take damage. Right, there we go, take damage. And there's going to have to be a couple arguments here. Right, like the first argument represents the object that we're calling it with. Right, like it's here we just decided to call it self. And then the second argument will represent the actual number that we're taking damage on. Right, so you see this 20 right here. Right, pretty much an enemy, right, gets passed into this first argument, right, and then next this 20, right, this will get passed into another argument. Now I'm going to call this probably like damage taken, right, because this is the number that represents how many we're going to decrement their health by. Okay, so let me zoom out a tiny bit. And once again, we're defining a function called take damage. Right? Enemy gets passed into self. Right? This is one of the tricky things about Python object-oriented programming. Right? This first argument is kind of invisible. It's with object-oriented programming, you know, the object to the left of the period, right, gets sent up into self. This was a little tricky. And then the take damage, right? This 20, this is the next argument. 20 gets passed into this variable called damage taken. All we need to do now is access their health and decrement it by whatever number was passed. So let me go ahead and access their health. Right, so it's going to be a self.health, right, and set it equal to whatever their health is, but minus the damage taken. Right, so let me go self.health minus damage taken. All right. So this is saying take their current health and set it equal to their current health minus whatever damage was taken. And that's what that's saying. That means when we pass 20, we're attempting to remove 20 from their current health. Okay, so let me rerun this class definition. Right, so rerun play. Okay, now let me rerun this testing cell, the user cell. Press play. Right, and there we go. Right, we see a new attribute. Right, you see how this take damage, it modified the Venom's health, and now they have 180. Okay. All right, hopefully people are kind of seeing what object-oriented programming can be like. Okay, so we're kind of just hard coding different scenarios here, but you might be able to imagine you can pretty much write a turn-based game with this. Like maybe, you know, in Pokemon, you know, things are taking turns and attacking each other. So if you kind of want to do that, you can maybe write a loop, right? Like write a while loop that goes through a certain amount of turns, and then maybe in each turn, each player has can choose to do something. I'm not going to do that here yet. Maybe, let's see, should we do that? Yeah, I guess we could. I guess we could do a turn-based game, just a little small one. But real quick, let's add another functionality that's opposite of take damage. Right, like in some in some RPG games, there is the ability to heal, right? The opposite of this. So let's go ahead and define the same exact function, but opposite. Right, so imagine we had a function called a heal. Right, this is the opposite of take damage. So let me go health, self, and then let me go, let me call the next argument a heal amount. Okay, so this is the opposite, right? All we're gonna do is take their health and then override it with their health plus whatever heal amount was specified. Okay, so I'm just adding one more class function. This, let me play this. This will give us access to increase their health now, right? Like let's say for some reason, right? Here you don't have to do this, right? Let's say for some reason the hero, heals, right? Like let's say the hero heals by like 50 more health. Right? You don't have to do this. This is just testing the heal function. Right? Basically, hero will be placed into the self, right? And then this 50 will be passed into this heal amount. So let me run this. Right? And we see that the hero's health got increased, right, by 50. Okay, so now that we implemented a couple functions that really just modifies the health, right, we can go ahead and let's see, and maybe do some sort of turn-based game. And so once again, you don't have to do this. I just want to show folks future directions of this player class. Right? Given this player class, you can give it to another person, and they can write a whole game based off of it. Right? So let's say we publish this to the world, and now the world can use this class. Right? So let's say down here they're attempting to use it, and maybe they're going to write some sort of turn-based loop. Right? I'm just going to have it do one turn for now. So let me comment this out, or I'm just going to delete it. Right? Like let's say we were playing some sort of turn-based game, and the hero goes first. Right? Like let's say I'm going to take an input. Right? This is a Python function that prompts the user for a string. Right? So I'm going to do input and say a hero, what's your move? Right? And let's say you can do something like attack or heal. All right, so once again, this is a Python function. We've seen it a few times. Right? All it does is it prompts the user, like hero, what's your move? Right? It's going to prompt the user. It's going to ask them to type something in, and when they type something in, this function will return whatever they typed in. Right? So I'm going to go ahead and store this into choice. All right, so here, let me just play this real quick. All right. Okay, so we're running it. We're stuck inside of this input function. Right? It's saying, hey, hero, what's your move? Right, so I'm going to go attack, right? Attack. And then the second I press enter, right, this function will finish and then return the string into this choice variable. Right, so let me press enter. Okay, there we go. I'm just testing this input function. Right? If anything, we need to branch based off of this choice. Like maybe if choice is equal to something, right? In this case, if choice is equal to attack, right? Or if choice is equal to heal. So here, let me just branch based off of that choice. Right, so if choice is equal to attack, then we can say something like we could say the enemy takes damage. Right, I'm just gonna put some arbitrary number here, like 20. Right, and then maybe another branch if their choice was heal. Right, so else if their choice was equal to heal. If we're choosing the heal, then maybe the hero will gain some sort of number. So I'm just gonna put heal like 50. just choosing some random numbers here. Okay, so here, let me run this again. Okay, there we go. I just ran it. All right, once again, we're stuck inside of this input function. I'm going to say attack. All right, we attack, and we should enter this branch. Right, the enemy should take 20 damage. So let me press enter. Okay, there we go. Press enter. All right, and see what happened here. Right, the enemy took 20 damage. Right, see how the venom is now 180 instead of 200, which is what we initialized it to. Right, here, let me run this again with a different scenario. Right, let me go heal instead. So let me rerun this cell. Okay, rerun. Okay, hero, what's your move? Attack or heal? Right, let me heal instead. So I'll type in heal and then enter. And yeah, there we go. Right, we see that the hero has more health. Right, 150, because yeah, we added 50 to its original health. Right, his original health was 100. Okay, so this whole cell is using the player class to kind of create a single turn. Right, so far, all this cell lets us do is do one turn. Right, but in the future, you might be able to loop this. Right, like maybe imagine this as being looped over and over again. Right, like maybe the hero and the enemy will take turns battling against each other. Right, in that case, you just have to loop these things right here. Right, you just have to loop these and change a couple variables around. All right, so yeah, that's kind of what object-oriented programming kind of looks like. Right, it looks like we define a cookie cutter. Right, a cookie cutter here is named player. And when we publish this cookie cutter, other people can use it to define their own objects. Right, in this case, the other people, they defined it as have a hero object, have an enemy object, and then we have access to a lot of different functions. Right, like if I were to do the user, right? Like let's say the user needed help on an object, right? So the user will just have to say, hey, help, give me help on the hero, right? Like what functions can I use with it? Well, we can use a lot, right? So help on the hero, right? We can heal, right? We can print our statistics, we can take damage. All right, okay. Cool. All right, I think that should be enough for this player class. Okay. Might do one more thing to this. I'm gonna do one more thing and then move on to the lesson. Hmm. What's up, Terrace? Oh, okay. Yeah, all good. Yeah, no need to ask to use the restroom or anything. Let's see. I think I might introduce something called a constructor and then start going through the lesson. Okay, let me see. Okay. Let me remove some things here. I'm going to remove this here just to simplify scenarios a bit more. All right. Okay, I'm just going to remove their turn-based. I'm just going to remove one turn. Now let's simplify this scenario a bit. What do you think would happen if we didn't initialize these variables? Right? Because here we're expecting the user to initialize the name and health for us. Right? This is kind of cumbersome. Right? Like back to the turtle example. Right? In the turtle example up here, right? Did we have to initialize their position, right? Like going back to the turtle here, right? If I were to let's see, let me just comment all this stuff out. Let's see, what should I comment out here? Yeah, okay, let me just comment this stuff out. All right, so let's say back to the turtle example. Right, if we were to actually, let me comment everything out. Excuse me. Thank you. All right, let's simplify this scenario a bit. So back to the turtle. All right, let's just deal with one. So one turtle. Were we ever required to initialize certain positions? Right, you could access the TU position, right? Like turtle one position is TU1 dot position. Right, so this is accessing an attribute, right? So we're able to access it, right? See, I just press play, and it says TU1 position is 0, 0. Right? Did we have to initialize it? No, right? We didn't have to initialize it, right? Meaning that we were able to access it right away. This means the library does some work behind the scenes. Right? Behind the scenes, when we construct this turtle, it's already setting the position to 0, 0. You don't really see it, right? But it is happening because when we printed it out, it's 0, 0. Right? It's also setting their attributes, right? It's also setting their other heading as well, right? Like if I do the heading, the heading tells us what direction it's facing. Right? See, do we have to initialize this heading? No, right? It's already initialized to 0 for us. So this is kind of convenient. Right? All the user has to do is declare an object, and that class will handle the initializations for us. Right? In this case, the class initialized the position and the heading. Right? So let's go back down to the RPG game. Right? In the RPG player, right, we're expecting the user to initialize things for us, which is kind of a broad assumption, right? Like these two initializations make it harder for the user to use your class, right? Because we're expecting them to understand the name attribute and the health attribute. Right? It might be safer to kind of initialize things to 0 in the very beginning. Like let's say we didn't initialize these. Right? So I'm going to comment these attribute initializers. Okay, let's say we didn't initialize it, and same with this enemy. Right? So I'm just commenting out these things. Right? So this is saying, hey, construct a hero, and then construct another enemy. So let me try to print it now. Okay, so there's not that many lines here, right? I know there's a lot of comments here, but we're just constructing two objects, and then we're attempting to print out their statistics. Right, so let's see what happens. So I'm gonna press play, and we get an error here. It says player object has no attribute name. Right, this makes sense because when we attempt to print the statistics, right, the name doesn't exist. Right, so this is going up to the function. Right, it's going up to this function, but these names and health has not even been initialized yet. Right, we just commented them out. So when we construct an object over here, right, typically there should be some default construction happening. Right, this will make it safer to use the class. Right, so once again, we called hero.printstats, right? But there's hero.printstats, right? And then it's going to the function, right? But we never initialized this. Right, so with the class definition, we're we're expecting the user to manually initialize these names and health. This makes it harder to use. Right? In contrast to the turtle, right? Going to the turtle up here, right? We didn't have to initialize these attributes. Right? The construction of the object already did it for us. Right? That's why we didn't get an error here. Right? There's no error that says, oh, this doesn't exist. Right? It does exist because the construction handled it for us. Right? So going back to the player here, right? The construction didn't really do anything for us. Right? So we'll talk about something called a constructor. Right? But basically, we need to initialize something called a name. So check this out. This is actually pretty cool. So this first line right here, this is actually calling a default constructor. Right? And the default constructor is a function in the class. Right? It's a specific name. Right? So it's in Python it's called init. And basically the constructor has a name, a special name. It's 2 underscores, right? So underscore, underscore, and then init, and underscore, underscore again. And once again, there's two underscores here, and 2 of them in the beginning. And then it's got a single argument called self. Now this is a special function, right? It's called a constructor. So let me just comment this real quick. Right, this is constructor for player. Okay. I can put this in one line actually. Okay, so the constructor for player, right? This is happening in this very first line, right? When we say hero is equal to player, right, it's actually going all the way up to here and doing something called an initialization. Right, so these two are related, right? This player and then the empty parentheses and then this initialization, right? Those two are related. So let's go ahead and define some things, right? Like when we construct a player object, right, typically some things would be initialized to a default number. Right? Like in the turtle example, right? In the turtle example, we saw that the position was initialized to 0, right? And then the heading was also initialized to 0. Right? Similarly with the player, right? Maybe we could initialize their name and health, right? Because those are the only attributes we have currently. Right? So each of them have a name. All right, let me just set it equal to not available for now. I'm just gonna say not available for now. This is for some safety. Yeah, so we're just gonna say the name is not available, and let me set the health as well. Right, self.health. Right, when we're constructing a default player, right, what should his health be? Maybe 100. Right? It doesn't really matter. Okay, so let's test it now. So I'm gonna run this. Right, this is a new definition. Okay, I just ran it, meaning that when we construct the player, it's going to automatically initialize these 2 attributes. So let me go down here. Okay, so this is calling the default constructor. Right, so I'm gonna run it. Okay, and we no longer get an error. Right, see what's happening here? Right, earlier we got an error. It said the hero didn't really exist. So basically we constructed 2 default things and then just printed it out. Right, the default is not available in 100. This might seem annoying, but it's actually safer. Right? This is a safer programming practice because when we're publishing the library, we're automatically initializing some attributes. Right? This way the user doesn't get a lot of weird errors. Okay, let's add one more thing to this constructor. Right, like this is kind of cumbersome here. Right? Earlier we had to set one thing at a time. Like we had to say hero.name is equal to Spider-Man, and then the health is equal to 100. This is kind of cumbersome. And in the constructor, sometimes it's possible to list some arguments. Like if we were to say Spider-Man here, and then 100, right? We're attempting to construct a player named Spider-Man, right? That's initialized to 100 health. Right, so that's attempting to do this. Right? I'm just going to delete this over here. And then same with the enemy. Right? Imagine if we made an enemy called Venom, and then maybe it's got an initial health of 200. Right? So check it out. This is going to be pretty cool. This is calling a constructor that doesn't exist yet. Right? So I'm going to run it. Right? It's saying that our constructor, right, takes one argument, but 3 were given. Right? This means that our constructor doesn't support additional arguments. Right? Like currently our constructor only has one argument. Right? It's called self. Right? But basically, self is implicitly passed in, right, from hero. Right? So hero gets passed in as self. Right? But we need to add in 2 more arguments. Right? One that represents their initial name, and then the other one that represents their initial health. So this means in our constructor, I'm going to add 2 more arguments here. Right, 2 more arguments. One is going to be their initial name, and then the other one is their initial health. Right, so those 2 arguments will be used to overwrite these attributes. Right, so here instead of NA, we can say initial name, and then in here we can say initial health. Okay, so we just updated this constructor to take 2 additional arguments, right? These initial name, initial health. Basically, the reason why is because right here, right? This is calling the constructor, right? It's passing 2 more arguments. Right? So let's go ahead and run this. I'm going to run this top one over here. Let's see. Let me run this class. Boom, run that. And finally, let's run this. So boom. Okay, there we go. And now we successfully constructed 2 objects with specific types. Okay, we're cool with this so far. Okay. Okay, I know this was kind of dense, all right, but here, let's summarize what we did. All right, we started off with a class player, right, and we ended up writing this function that just prints out their stats. And later on, we wrote some more functions that adjusted their attributes, right? Like we got to heal, we got to take damage, right? And then we ended up writing a constructor. Right? Once again, the constructor is actually being called twice over here. All right, that's yeah, George.
Is there any chance where you can add like a level up system, like increase the health like from say 100 to now to 100?
Oh, I see. Yeah, that's a good question. Is there a way to, maybe increase their max health? Yeah, that's a good one. Yeah, there is. Actually, so currently these players have like an uncapped health. Uncapped, meaning that the user can kind of hack your game. Right? The user can kind of do something like hero.health is equal to like 1 million. Right? And this is kind of like hacking it because there's no cap here. Right? So now we're at 100. So yeah, George was asking, is there a way to kind of cap this or have them level up, right? If anything, we have to add in some more attributes. I'm going to keep it simple for now, but basically you'd have to add in some more attributes that represent how big their health can be. Like maybe maybe you can add in some more attributes that represent their max health, right? Like let's say they have something called max health, and let me just set it to like, let me just initialize it to some number. Let's just say like 100 for now. So basically, if you want to implement a level up system, right, you'd have to define the caps, right, meaning the capacity. So yeah, I'm not going to implement a level up system yet. Oh yeah, I see what you mean, George. If anything, it might be more appropriate to implement something called like an experience, right? Like maybe every player has an XP, right, experience that sets to 0, and maybe during the game, right, we're gonna increment this experience, right, and based off this level up system, right, their attributes can rely on this number. So like basically, the higher your XP, maybe the higher their health can be. Yeah, that's a good one. Okay, so that's about it for a player right now. Right, all we did so far was write a representation that kind of stores their name and health. Right, we didn't do the stamina and mana yet, but folks can do that later if they want. Okay, so I know this was a pretty dense example, so we're gonna redo all of this in the lesson. Okay, so let me quit this. Okay, we're done with this. We did a turtle example and an RPG example. Okay, let me quit this and go back to let me go to lesson. Okay, so once again, we're on the very last lesson and the very last lab. We'll do the lab together on Wednesday. So let me just open up the lesson for now. Okay. So yeah, here's the very last lesson. We'll do the same exact thing, but kind of build it from scratch again. Okay, so classes and objects. Once again, a class is like defining our own type of variable, and an object is the actual thing itself. So if we were to declare, let me define a simple class over here. Right, so the bare minimal syntax we need to define our own type of variable, right? It's like a class simple. Right, we're just going to call it simple for now because it's not going to have that many things in it. And typically there's a doc string that kind of represents what it is. Okay. So I'll run this cell. And yeah, all this cell does is it defines a cookie cutter. Right? A cookie cutter, once again, is not the actual object. It's a generalization of the object. If we were to create a cookie from this cutter, right, we would use this. We would use this notation here. Right? This next notation is saying, "Hey, create an object named instance." Right here, we're just calling it this. This is short for instance, and we're setting it equal to this cookie cutter. Thank you. So yeah, let me go ahead and declare that. All right, so I'm gonna say instance is equal to this cookie cutter. All right, once again, let me comment this. Right, this is declaring an object named instance, right, from the class simple. Okay, so let me play this. Cool, we declared it, and yeah, if you want, you can print out the type. Right, you can print out the type. It should print it simple. The type of simple is, let me just print the type of instance. Right, this is just going to help us visualize. Yep, there it is. Yeah, type of simple is class simple. Right, this is just this earlier definition. Okay. And yeah, once again, we can see the doc string for that class. So if I go help, I can go help on the instance or help on the class, right? It's the same thing. If anything, this is more specific, and it's going to give us some functions that are available to us. Now, you don't have to worry about this stuff yet. This is actually just built-in attributes to every single Python object. You don't have to worry about it too much. Basically, our class doesn't really have anything. So what we're going to add on to it, and this documentation will get a lot bigger later. Okay, so help on instance or help on simple, right? Same thing. Right, just imagine that we have nothing, right? We only have these built-in Python things. Okay. So let's add on to this class, right? So far, this class doesn't really do anything. Let's add on to it. Like, let me declare another instance. Right? In this case, I'm just going to call it 1. Right? So this is creating an object, right? So this is creating. It's actually constructing, right? To be more specific, right? We're constructing an object named 1 from the class simple. Okay, so we're just going to create one, and let's go ahead and initialize some attributes to this class. Right? In this case, we could pretend like this class is representing someone's profile, right? Like let's say someone's profile has a name associated with it, right? So 1.name is equal to a Mike. Right, we're just hard coding some names. Right? It's like our player class. Right? Remember our player class? We had a name, we had a health. Right? In this case, we're just gonna initialize name and then maybe their job. Right? 1.job is equal to instructor. Right, okay, there. Let me run this. And oops, unterminated string literal. I gotta be consistent with these double quotes. My bad. Okay, there we go. So I just constructed an object and then initialize a couple attributes. Right, so let me just comment this out. This is initializing a name attribute. And then this next one initializes a job attribute. Right? Okay. Cool. So there we go. We have one instance called 1. Okay. Let's go down a bit. Let's create another instance, right? And then print them both out later. Right, so this doesn't have any output because we never printed anything, right? We're just kind of constructing things. Right, we'll print later. It's going to be pretty cool, right? We'll see 2 different ways of printing. Let me go ahead and declare, construct another person. Right? And once again, this person comes from the class named simple. So let me declare another one. I'm just going to reuse this cell over here. Right, let's say 2 is equal to simple. Right, and then we'll say 2.name is equal to Dan. And 2.fam is equal to Mike's brother. Right, so there's kind of 2 weird things here. Right? Basically, they have different attributes. Right? Like the first one had a job, but the next one doesn't. Right? So it's possible for classes to have different attribute types. That's kind of what this is showing. Right? The only similarities is their name. Right? They both have a name, right? But the first one has a job and the second one has a fam. So it's kind of like different attributes for the same class. Okay, let me run this real quick. Okay, there we go. And let's go ahead and start printing, right, so we can visualize what's happening here. So let me go ahead and print. Right, once again, when we print with, we can access the attributes. Right, each of the attributes have a name string, so we can say print one.name. Right, this is saying, hey, print the name that's associated with this object. Right, and then print the other name, two.name. Right, we'll see it says print Mike, right, and then Dan. That's what we initialized earlier here, right? Name and then 2. Okay, and we can print some other stuff too, right? Like we could access Mike's job, right? We could print one.job, right? And that'll print Mike as an instructor. Right? But once again, when we try to print Dan, right, 2.job, right, this is not going to work because Dan doesn't have an attribute named job. Right? So far, the second instance only has something called fam. Right, so I'll do fam and Mike's brother. Right. So yeah, we'll do a constructor later. Right? Basically, a constructor is kind of secure because it'll protect us from these types of errors. Right? Like basically, constructors would initialize their job to some default value. Right? This way, when we print it out, it'll print out whatever their initial value is, like maybe an empty string. So this will make sense in a bit, right? We'll do a constructor later, which will protect us from these sorts of errors. Okay. For now, I'm gonna go ahead and change this initializer to job, right, just to simplify things a bit. So let's be consistent, right? I'm gonna change this to job, just so every instance will have the same exact attributes now. So there you go, fix that, meaning that we should be able to print out jobs, right? Job. Looks like Dan's job is Mike's brother. Yeah, that's an okay. Yeah, I'm just trying to be consistent with the attributes. Okay, let's go ahead and wrap this in a print function. All right, we'll see two different types of functions that will print. Right, we'll see a normal function and then a class function. So one way we can write a normal function is one that doesn't belong in the class. Right, so earlier in the player example, let's see. Right, earlier in the player example, you might remember we had a class function. We're not going to do this yet. Right? This class function belongs inside of this class player. Right? We're not going to do this yet. We'll do the original style first, right? A non-class function. So scrolling back a bit to the lesson, right? Let's say we were to wrap these in a function, right? Like this is kind of cumbersome. Right? Like, wouldn't it be more convenient if we did something like a print stuff? Right? Like let's say we had a function called print stuff in simple, and we passed it like the instance, right? Like 1 right here, right? And then do another one for 2. Right? Basically, I'm attempting to call a function that will do the work for us. Right? In this case, we're expecting these functions to kind of just print 2 lines. Right? That's what we're expecting here. So let me go ahead and try to call these. Right? If anything, print stuff in simple doesn't exist yet. So let me go ahead and make it exist. Right? So in the cell above, right, I'm gonna define a normal function, right? Meaning it's not a class function. So define a normal function. It's called print stuff in simple. right? And this is going to take a single argument. This argument is just a instance. Right? So the most general way we could call it is instance, or inst. Right? Meaning that when we call these functions, like when we invoke them, right, 1 will be passed into here, and then 2 will be passed into here. Right? All we need to do is print 2 lines now, right? Because the goal of this function was to kind of just dump out their attributes. So let me just dump out the attributes, right? Like a name is, I'm going to use an f string instead. Name is the instance.name, and then the job is the instance.job. Okay, so we're defining a normal function, right? Meaning that this first one will call this function over here, right? It's printing 2 things, right? So this first function invocation prints that, and the second one prints this right here. Right, people cool with this so far? Okay, cool. So this is a non-member function, right? Meaning that it's not really attached to a class. In the player example, we saw a different style. So going back to the player example in the beginning, right, you might remember we had a print stats function. This is actually a member function, meaning it belongs to the class player. Right, so a different style we could print is object-oriented. Right, this is not really an object-oriented print. Right, an object-oriented print would be more like instead of this first line, right, a different style would be, 1 dot print stuff in simple. Right, so there's kind of 2 styles here. This is not going to work yet, by the way. And then 2 dot print stuff in simple. I'm going to delete this in a bit, but I want folks to kind of see the difference between this. Right, this first one is not really object-oriented. Right, it's calling a normal function and then putting the object here. Right, but this next one is more object-oriented because we're calling an instance and expecting that instance to have a function. Right, this second one we're going to do next. So let me delete these because we're going to define those in just a bit. Okay. So yeah, we'll talk about member functions. Basically, these are functions that are inside of classes, right? Meaning that the cookie cutter has access to certain functions. Right? In this case, we're going to add on to the simple class. Once again, if you scroll up a bit, our class currently has nothing in it. Right? So here, our class currently just has nothing. Right? It's just this. So let me add on to this class and add a member function. So let me scroll down a bit. Right, we're going to override this class. Right, override means to add functionality to it. Okay, so scrolling down a bit. Okay, so our original class definition was just this, or just class simple. Let's go ahead and add one more function to it. Right, make sure there's the indentations here too. Yeah, I'm just going to add one more thing called print stuff. Right, I'll define something called print stuff. Right, it's going to be a different style. Right, basically, we're going to put something called a self in here. Right, this will make sense in what self is. Right, it'll make sense in a bit. Right, self is actually an implicit argument that will be passed later. Right, so if I were to just print the stuff, let me do a print statement here. Printf name is self.name. Right, once again, self, but this will make sense in a bit, right, when we call it. And let me go ahead and print the job. Job is self.job. Okay, so let me run this cell. Right, all this cell is doing is overriding our previous class. by adding on another member function. Okay, so let me run this. Okay, there we go. We just redefined the class. Let's test this brand new function. So let me just declare another object. Right. So once again, if you want to declare an object, you can just call it like instance. Or you can call it whatever. Right. I'm just gonna call it instance. Comes from the class sample. All right. Once again, this is constructing an object named instance from the class. Right, we're constructing an object, and then let me initialize a couple of things. Right, for example, let me initialize the name. I'm just gonna say Andrew Tack, right, my name, and then let me say let me initialize the another thing like the job. Right, instance.job is equal to instructor. Right, I'll just call it like CS instructor. CS CIS. I'm in two departments at Cabrillo, the CS and the CIS. Okay, cool. So I initialized two things. Okay, run the cell. It doesn't output anything yet, but once we invoke the function, it will. Right? There is a function called print stuff. Right? But here's the part where the self keyword might make sense. So the object-oriented style usually has a period, right? Meaning that to the left of this print stuff, it would be the name of the object. Right? The name of this object is inst, for instance, right here, and then period. Right? So all I did was I said, hey, object dot print stuff. Right? So this is invoking a member function. Right? It's invoking a member function of the class simple. Right? So this is going to pass. It's going to go up here. Right? It's going to go up here. Let me zoom out a bit. Right? You see this argument self? Right? This is an implicit argument that's passed in object-oriented style. Right? But basically, this when we call instance.printstuff, this instance gets passed into this argument, so we're referring it to it as self. All right, so let's print it. Right, see, there we go. Right, instance.printstuff. It's just going up here. Right, instance is now called printstuff. I mean, it's now called self. Right, and we can go ahead and print some other stuff too. Right, like you might remember we have more objects. Like you might remember we had a 1 object, right, and we had a 2 object, right? We can go ahead and print their stuff too. Right? These are from earlier. So let me do print stuff and 2.print stuff. Okay, let me run this. It should print more things. So there we go. And let's see. Oh, a simple object has no attribute. Oh, so 1.printstuff didn't exist. Oh, you know why? It's because we got to reconstruct these. My bad. So let me just copy and paste some things here. Yeah, let me just copy all of this here. Put it down here. All right, see, we can initialize some more things. Right, like here we initialize something called instance. All right, let me initialize 2 more things. So I just copy and pasted some more stuff here. Okay, I just copied and pasted this highlighted area. All right, we're constructing more objects. And yeah, we can just invoke their member functions, right? Like 1.printstuff, and then 2.printstuff. And then let's run this. And yeah, there we go, right? We just get more print statements. Right, this is the first instance over here. Right, this is the next one, and that's the next one. Okay, so yeah, the goal of this was to talk about member functions. Right, the tricky part about member functions is this self variable. Right? So there's a visualization somewhere right here. Right? Like basically the self variable is a implicit argument. Right? In the object-oriented style, right, the thing to the left of this period, right, gets sent into self. And that's kind of the tricky part when we're doing member functions. Right? There's kind of like this invisible argument. Okay. Okay, let's see. Let's add on some more functionality and then talk about constructor, and then we'll be done. Okay, let's add one more member function to this class. Right, so far, this class only has one member function. Excuse me. Thank you. Yeah, so far this class only has one member function. Right, let's extend this. So I'm going to copy this and then add in another to it. So let me scroll down. Scroll down a bit. Let's see. Okay, let me go here. Okay, so down here, I'm gonna override the class. Right, I'm gonna redefine this simple class and add on one more member function. Right, the goal of this next member function is just to kind of modify a certain attribute. Like in this case, we're gonna modify the name. Right, so the point of this function is to let the user modify the name through some user input. So let me go ahead and define something, like define a function called input name. Okay, so once again, the goal of this, let me create another cell. Right, the goal of this is it would be beneficial to the user to not have to set certain names, right? Like earlier, we had to say, well, we had to initialize manually. Like we had to hard code things. Like we had to say instance.name is equal to something, right? Is equal to something. But this was kind of cumbersome because, you know, imagine this top cell as the programmer giving the user something, and then this next cell is the user, right? Here, so here the user is expected to initialize some attributes, right? This is kind of dangerous and cumbersome because, you know, we can't expect the user to know everything about your class. We want to give them an easy chance. I mean, an easy workflow. So it might be useful if we were to be able to have a member function called input name. And so imagine if there was a function called input name. Right. The goal of this function is to prompt for user input. Let's say, let me rerun this over here, rerun this. Right. Oh, let me put in an argument here. Right. The goal of this is to enter a name. Right. So this is really just going to wrap a function called the input. Right. This will let the user type in something and override their name attribute. All right, so let's go ahead and get this in. We need to define a function called input name. Okay, and it's actually going to take two arguments here. Right? Basically, the first argument is the self. Right? This is the implicit argument that gets sent here. So I'll just call it self. And then the next argument is right here, right inside of this function. Right? This is actually a prompt. You can call it whatever. Now, the goal of this next function is to take input from the user. Right? Like take input. There's a function called input. And then in this case, the prompt will be whatever we passed in. Right? So it's just going to say enter a name. And when we press enter, this will store the string into some variable. In this case, I'm just going to store it in some variable called name, right? Self.name. Okay, so just to kind of comment this a bit, let me rerun this cell, and I'll comment it in a bit. Okay, so let me run this. Right, we're going to construct something called instance, and then call a member function that will ask for something. Okay, so there we go. Right, we have instance is equal to simple, and then now we're stuck inside of this input name function. Right, this function goes up into this member function, and we're stuck inside of here. When we type something in, let me type in Andrew. The second I press enter, this function will finish, and then we'll set this attribute to whatever we typed in. Right, so I'll press enter. Right, there we go. Right, there's the end of it. All right, if anything, we should probably print their stuff. This way we can visualize the output. Right, like let me invoke the print stuff member function. Right, so instruct instance.print stuff. Right, there we go. Let's test this. So let me run this. Okay, so we're stuck inside the input name function. Let me type Andrew, enter, right, and hopefully it prints out our stuff. So I'll press enter. Boom. Okay. So it did print the name. Right, it did go into the print stuff function here. Right, it succeeded on this first line, but then this next line it failed. Right, see here, it's pointing at self.job. Right, it's saying we never initialized this. Right, this makes sense because when we constructed our instance, right, the only attribute we set was the name. Right, so down here, this is actually called a mutator. Right, it's a mutating. Is changing the. It prompts the user to change the name attribute. Right, it's a mutator, meaning that the point of this function is to change some attribute. Right, we're mutating some attribute. In this case, it's just the name. But once again, we have an error. Right? This error does make sense because we never initialized the job. But we never initialized this. So, this is where the constructor might help. Right? The constructor's job is to initialize default values to like some default number. So here, let me add a constructor up here. Right? The goal of a constructor is to initialize attributes. This way we can kind of avoid these types of errors. Right? Like we're expecting each class to have this job attribute. But the way we invoked it, right, we're expecting the user to change the job for us. Right? Like we're expecting the user to do something like instance.job is equal to something. Right? Some job. I'm just keep it like this for now. Right? This is kind of annoying because we don't really want to expect a user to modify every single attribute. See, it does work right here. I'll type in Andrew, right, and it both works now. Right? Our name got initialized, and then we manually initialized this next attribute. If anything, it might be cleaner to do this in a constructor. Right? So let's go ahead and define a constructor that will initialize these attributes to some initial value. So I'll go up here. Right? The special syntax for it is once again 2 underscores and then init and another 2 underscores. And it takes a self argument. Right? So this is called a constructor. Right, so the constructor is called over here. Right, so in this testing cell, this is invoking the constructor. So we're invoking the constructor. If anything, we need to, once again, set some default values. We are expecting this class to have a name and a job. So let me just initialize them to something. Right, like let me say self.name. I'm just going to initialize it to a not available for now, and then initialize the job to not available. Right, this is saying when we construct an object, right, we don't know their name and job until later. Right, so that's like right here. So here, let me run this cell. Okay, there you go, run. Okay, let's run this now. Hopefully the print stuff works, right? Because this constructor should now initialize this attribute for us. Okay, so let's test this. So let me run this. Okay, cool. So we just finished constructing, right? Meaning that it did these 2 lines for us already. Right? And then now we're on this next line. We're attempting to mutate the name attribute. Right? We're stuck inside of here. So let me enter Andrew Tack. Right? And once I press enter, right, the name will get overridden. So let me press enter, and boom. Right, override the name. Now we're printing the stuff, right, and we get no more error. Right, see, earlier there was an error that said, oh, this doesn't exist. Right, but this constructor now gets rid of that error. Right, it's protecting us from printing things that don't exist. Right, if anything, we just initialize the job to not available. Right, this is better than seeing an error, because if you see an error, it's kind of stopping your whole program. Okay, hopefully people are cool with this so far. Yeah, we just added in a constructor. Right, if we didn't mutate the name, right? So let me just comment this out. Right, if we didn't, what's it going to print? Right, just print NaNA. Right, this is super safe. Right, so see, look how safe this is. Right, if we didn't have a constructor, right, I'll comment this constructor out. This means that this print function is no longer guaranteed to work. Right, it's attempting to print things that might not be initialized. So let me rerun this cell. Right, so rerun, and then let me run this. Okay, there we go. Right, we got some errors. Right, it's saying the objects have no attribute name. Right, and it's also going to fail down here, right, because we never initialized that as well. So hopefully people kind of seeing what this constructor lets us do. Right, it's like a safety thing. It's initializing default values, which will guarantee that these member functions should work. I just uncommented out the constructor, meaning that this print statement should work. Right, these self.names are initialized to some value. So let me rerun this and rerun here. There we go. See, no more error. Right, this is, once again, seeing these NAs are much better than an error. Right, an error is like crashing your program. Okay. Okay, hopefully people are cool with this so far. Cool, so far our simple class just has a constructor. It's got a accessor. An accessor is like kind of just dumping out the data, right? Dump out data. And then we got a mutator here, which pretty much just modifies an attribute. Okay. Okay, we'll finish the rest of this on Wednesday. Let's see. Yeah, we'll be done with this lesson on Wednesday. I do want to give a heads up that this later part of the notebook is kind of optional. There's a part here called class design. I don't think we'll have time to go over this. So it's pretty much about inheritance. Inheritance means you can make more classes that rely on the previous class. We're not going to cover this. The next class will for folks who are going into CS20P. So yeah, just feel free to collapse this. We're not going to get into this class design too much. If anything, we're going to go all the way down to this blog entry. Okay, so yeah, once again, we're a bit over time in class. We'll finish the rest of this lesson on Wednesday. Right, we're pretty much gonna add another argument to this what's it called, constructor. Right, we're gonna add an optional argument, which will allow us to add in some more add-in arguments to this constructor. Okay, thank you all for coming. See you all again on Wednesday.